What's happening, you guys? Welcome to today's session. My name is Anoop and this here is Vedantu 9th and 10th English channel. I hope that all of you guys are doing good and taking care of yourself. This is going to be a very interesting session. In today's session, guys, we're going to understand about EMF or electromotive force, terminal voltage and internal resistance. It's a very interesting concept, but you have to stay till the end so that you understand everything. We'll also be solving a lot of very important problems as well. So make sure that you get your pens and paper ready and note down all the important points that I'll be telling today. And also, guys, you can download the notes as well. All the handwritten notes, you can download it in the description below. So don't worry about that as well. Everything is covered. With that said, guys, let's get into today's session without wasting any more time. So in today's session, people will be looking into a very important concept of this EMF, terminal voltage and internal resistance. But before we get started, as always, we never start a day without a positive vibe. So today's positive vibe or a quote for today is this: if you have good thoughts, they will shine out of your face like sunbeams and you will always look lovely. Now, you know this, guys. Like, imagine your closest friend. Even without them saying that they're sad, or them they're saying, even if they don't say that they're sad or happy, you can easily understand just by looking at their face. You know that here, your friend, he or she is sad, or he or she is, happy about something. So when you have happy thoughts, when you have, good thoughts, without you even conveying the message, people around you will get it. Just by looking at you, just by interacting with you, they get that positive vibe. So always try to be that one positive person that they can look out for, rather than someone who's always frowning, always complaining about something. Be that positive vibe so they can influence people around you in the right manner. Because not only does it uplift your thoughts and your feelings, it also helps uplift the people around you as well, right? So that's guys, let's get into today's session. It's a very interesting quote which you can apply in your everyday life. Anyways, with that said, let's get into today's session. EMF, internal voltage and internal resistance. Okay, let's get into it. Now, EMF stands for electromotive force. Looking at this word, electromotive force, many of us, including me, the first time I heard this, I thought it's a type of a force. Just like how you have frictional force or nuclear force or mechanical force, even I thought that it's nothing but a type of force. But the fact is, people, it is not really a force. It is not really a force. The name, although ends with the word force, it's not actually a force. Now, back in the day when the whole discovery of electricity happened, when the whole discovery of electric cell happened, people thought that because you could use a cell for different purposes. You could use it for running a bulb. You could use it for running a fan or any other electrical equipments that you can think of. So what people thought was that the cell is creating a force, or the cell is providing a force because of which the work is done. But later on, we understood that it's not exactly a force, it's something else altogether. The name, although remained as electromotive force, but it's not actually electromotive force. Alright, let's take an example. For example, guys, if you have an electric cell and you have connected to, a simple bulb, what happens when you turn on the switch? The bulb would turn on. Now, you know that this is happening. Why? Because of the flow of charges. So the charges end up flowing from the negative terminal and it goes all the way to the positive terminal. So that is how the charges are flowing. So the charges are flowing this way. And then you have the current which is flowing in the opposite direction. That is from the positive terminal to the negative terminal. And the flow of charge is what is called as current, and that is what leads to the lighting of this bulb. Now, what is this cell? A cell is a simple electrical equipment, or you can say that it's a source which basically provides something called as potential difference. Now, we've already seen what is potential difference in the previous session. If you haven't watched that video already, please make sure to watch that. That is the first ever session that we did, so make sure that you watch that. So basically, a cell provides a potential or creates a potential difference because of which the current is flowing. Now, remember this, guys. Cell do not produce charge. Cells do not produce charge. The function of cell is not to produce charge. It is to give energy to the charge. Listen carefully. So when the charge starts to flow, what happens is once it enters into a bulb or as it is flowing through that through the wire, it loses its energy. It loses its energy because of resistance. It loses some amount of energy. And as it is about to basically once it leaves, as it is flowing through, it is losing more and more amount of energy. And by the time it reaches the cell, it has almost lost a lot of its energy. As soon as it enters into the cell, what does the cell do? The cell will give more energy to it so that the charge can again start flowing in through the entire circuit. So what is the function of the cell? It does not produce charge. Charge in the sense it does not produce the electrons. It is not actually producing electrons. It is just giving energy to those electrons so that it can go around and complete that one simple circuit. That is what you have to understand. This is the first misconception that majority of us have. It is not that it is producing charge, it is basically giving energy so the charged particles or these electrons can move around. Alright, now here's the thing guys. This here is called as an electrolytic cell. So in an electrolytic cell, what you have is basically an electrolytic solution or an electrolyte. Basically, it could be an acid or it could be a base, because they have ions inside them, and these ions would help in the conduction of electricity. So you have basically two conductors which is dipped inside this electrolytic solution. One is called as the anode, the other is called as the cathode. So anode is positively charged and cathode is negatively charged. So in other words, the anode is connected to the positive terminal of the cell and the cathode is connected to the negative terminal of the cell. Now, the function of the cell is to maintain a proper or even potential difference. It's basically able to create a proper potential difference so that the flow of charge continues to happen. So it is trying to maintain a flow, basically it is trying to maintain that potential difference so that the charge continues to flow. So what happens, the charge would start flowing from the negative terminal and it will get into the, basically because of the ions, there is electrons being, electrons and the positively charged ions, anions and cations, they also start to move and there is conduction of electricity happening. In other words, the circuit is complete, and if you have connected a simple resistor or something, you can check the potential difference across that resistor as well. Simple, very, very simple, an electrolytic solution. Now you also have another kind of electrolytic solution called as a galvanic cell. So in a galvanic cell, we don't have a separate cell. We don't connect it to a separate battery. We just have a simple electrolytic solution like this. So you have electrolytic solution. So this is the electrolytic solution. You have basically you have the anode and the cathode, and let's say that you've connected a simple resistor like this, and this is what is called as a galvanic cell. So here in a galvanic cell, the electrodes and the electrolytic solution, that is the one that acts like the cell here. It is not this. So there's no external battery or cell connected to it. It is this electrolytic solution. It is this, basically, what is it? It is nothing but this electrolytic solution and the electrode. That is the one that is acting like the cell. So if you have to draw it in a simple circuit, this is what that circuit would actually look like. So you have, the positive terminal and the negative terminal, right? So yes, so that is what it would look like. So that is what is called as a galvanic cell. Now you don't have to go by my word right now, because you'll be studying this in your higher grades, but this is just for your understanding, right? So that is the one that is basically creating the potential difference, and this is some resistor with, let's say, 4 ohms or 2 ohms, right? Now here's the thing, listen to me very carefully. When the electrons or the charges start to flow, that is what basically when the electrons continue to flow, when it completes the circuit, that is when you see that the circuit is a closed circuit, and you can see that if you've connected a bulb, it starts to work. So here, when the electrons are basically flowing, so let's say that this is the negative terminal, this is the positive terminal, so that is the anode and the cathode. So you see that when the electrons are flowing from one terminal to the next, basically it's flowing through through this electrolytic solution, what happens is that they start to collide. The electrons will start to collide with the other ions and everything. So what happens is that there is an internal resistance within the cell that is created, because of which the output might not be as much as you think. Now, where am I getting into? Listen carefully, guys. Listen carefully. For example, if you go to a shop and buy a set, let's say you buy a cell, something like this, 1.5 volt cell. So this is the voltage, it's 1.5 volt cell. Now, the manufacturer would say that this cell will be able to give you a potential difference of 1.5 volt. That is what it means. But do you actually get 1.5 volt? No, you will not, because nothing is ever ideal, because there is resistance inside the cell also. Because the type of material that it has, there will be resistance inside the cell as well. Now, hear me out, people. This value, the maximum value, that the maximum energy, because that basically that what is that 1.5 volt? In other words, it is able to give so much of energy to the charged particles, to the charge. So here what is happening is that the value that is mentioned, if it's a 12 volt battery or a 1.5 volt battery, the maximum voltage or the potential difference across two terminals, across the positive and the negative terminal, that is called as the EMF, or electromotive force. The maximum value that it can give. So like I told you guys, a battery's function is to give energy to it. It is to supply energy to it. So the electromotive force basically is nothing but the maximum value of voltage or potential difference across two terminal. That means, hear me out, people, that means when the current is not flowing through the circuit, because when current starts flowing, because of internal resistance, the voltage drops. But here that is not happening. So what is the maximum value when you have just bought a new cell? Whatever the value is, whatever that value is, 1.5 volt or 12 volt, that is the EMF. That is the EMF. That is a maximum amount, so that is a maximum amount of energy that can be supplied by the cell. That is what is called as your electromotive force. Now, the electromotive force ensures, people, the function of this ensures that there's always a potential difference created so that the current can flow through that circuit. That is what electromotive force is all about. Now, the thing is this, guys. If you have to define electromotive force, again, what is electromotive force? The energy spent, because obviously to move those electrons there is some amount of work done. So for you to do some work, there should be some energy spent. So that energy spent per unit charge or on a positive test charge to complete the circuit, the amount of energy that is spent to complete on a unit charge to complete one circuit, that is what is called as EMF. But yes, guys, as you go to your higher grades, you will understand there is other definitions also for it. So one of the other definitions of EMF is that the potential difference between two terminals, when there is no current flowing through it, that is also what is called as EMF. In other words, the maximum current, because obviously when you connect it to a circuit, because of internal resistance and all that, there is some voltage drop happening. So what is the maximum value? That is what is called as EMF. But again, the SI unit remains the same, people. It is nothing but voltage itself. The SI unit is volt itself. It is work done, again, work done by Coulomb. So it's nothing but we have already seen that about potential difference. But the symbol to denote is nothing but E. So basically you denote it as the letter E. Let me use a different color so you can see it clearly, people. So it is denoted as the letter E. So it's denoted like that, like the cursive letter E. And again, that is the definition. And again, people, it is what is it? It is nothing but the work done to take a test charge around it. In other words, the energy spent to take that test charge or that unit charge around that circuit. That is what is called as EMF. Now, there are certain factors that EMF depends on. One of the factors that it depends on is the type of material that is used. So the type of electrode that is used, it could be graphite, it could be a metal, whatever that is something that it depends on. And the type of electrolytic solution also, it depends on that, because some of them might offer more resistance, some of them might have less resistance. So the type of electrolytic solution or electrolyte that is used, that also is something that is considered when you talk about EMF or electromotive force. The factors that it does not depend on or is independent on are nothing but the shape of the electrode. It does not matter whatever the shape of the electrode is. It does not really matter on that. The distance between the electron is also something, that is also something that is ignored, and also the amount of electrolyte. It could be 1 liter, it could be 0.5 liter, it does not matter. As long as the electrodes are submerged inside that electrolytic solution, it would definitely work. Right, now let's get into it. Alright guys, imagine this. Imagine there is a simple circuit. So I have a resistor, let's say it's a 4 ohm resistor, and this is basically the cell. Alright, so let's say that this is a 12 volt cell. This is a 12 volt cell. Now, what is the current flowing through the circuit? So if I have to calculate what is the current flowing through the circuit, we already know that current is equal to, so basically V is equal to I into R from Ohm's law. We've already seen that. So I is equal to what? V by R. What is V? V is nothing but 12 and R is nothing but 4. So 4 3s are 12. It's nothing but 3 volt. So 3 volt is the current flowing through it. 3 volt is the current flow, 3 ampere, not volt, 3 ampere is the current flowing through it. 3 ampere is the current flowing through it. Now this is theoretically, this is supposed to be the ideal case, but the fact of the matter is, people, because of the internal resistance, in other words, because of the resistance inside the cell, which basically is represented by a smaller zigzag line, this is called as the internal resistance. So internal resistance, so I'll take this as the external resistance R. Internal resistance is small r, which is nothing but the resistance inside the cell. So again, if we go back to this example, the resistance that is there between, when the electrons are flowing, the resistance between the particles, because of all the ions and everything, they collide, and the resistance of that cell, that is called as the internal resistance, which is represented as R. Because of this internal resistance, you are not getting the output that you really want. So a 12 volt cell, if I check what is the voltage across this point, if I want to check what is the voltage across this point, how will I calculate it? Let's say the internal voltage is somewhere around 2 ohms. All right, the internal voltage is 2 ohms. It's a 12 volt battery itself. And now I want to check again, what is this? This is nothing but the EMF. 12 volt is the EMF. 12 volt is the EMF. That is the maximum potential difference that across that particular terminals. Now, if I want to calculate what is the voltage across R, again, let's try to calculate the current over here first. So how will you calculate the current? Again, this resistor is nothing but 4 ohms itself. So the current is equal to, again, V by R itself. But this time, resistance is not just this resistance. It is an addition of both of these, because there is resistance inside the cell and there is resistance in the external circuit as well. So what happens? So it will be 12 divided by 6, 4 plus 2, because it is the complete resistance. So what will happen? It will become 6 2s are 12, so that will be 2 ampere. So the actual current that you observe in this is that it is actually 2 ampere, not 3 ampere, it's 2 ampere. So what will be the potential difference across this resistor? What will be the potential difference? So again, V is equal to I into R. Current is 2 amperes, resistance is 4. So what will be the voltage? It will be 8 volt. So the potential difference across that resistor is 8 volt. So what does that mean? The manufacturer promised that I'll be getting a 12 volt, the output is going to be 12 volt, that is the potential difference is going to be 12 volt. But what am I actually getting? I'm getting 8 volt. I am actually getting 8 volts. So there is a voltage drop happening. I am not getting what I was promised. Now this is the case with pretty much everything, right? For example, when you buy a pizza, they tell you the cost is 200 rupees. But by the time you pay the bill, they'll add some GST and SST and all that, and then finally you get something, right? You'll get it as 300 or 400 rupees. Now what I'm trying to say is this, guys. Just like that, in real life also, when you talk about a cell as well, they promise you that the voltage is going to be 12 volt. That is your EMF. But what you get is going to be far less than what they had promised. That 8 volt, this is called as the terminal voltage. What is this called as? This is called as a terminal voltage. In other words, it is nothing but the voltage between these 2 points. the voltage across those 2 points, because this is the resistance inside the cell, so that is the entire cell, that is the cell. That small r is nothing but the resistance inside the cell, right? So it's nothing but the entire cell itself. So the potential difference across those 2 points, or across the terminals, the positive and the negative terminals, that is what is called as the terminal voltage. Or in simple words, you can say that it is the voltage in the external circuit, not inside the battery but outside the battery, the external circuit. What is the voltage? That is what is called as terminal voltage. Now hear me out, people. They promised you, so EMF is 12 volt, the external voltage V is equal to 8 volt. So there is a potential drop happening. So basically there's a change, or in other words, there's a potential drop happening. That potential drop, which is represented by small v, is equal to EMF minus the internal voltage, which is nothing but 4 volt. So what is happening is that they had promised you 12 volt. What you're getting is 8 volt. The battery that is there is eating up the rest of the 4 volt. The battery that is there, it is eating up the rest of the 4 volt because of the resistance inside the battery, because there is nothing that is ever ideal in life. Right, people? This is the entire concept. In fact, just if you understand this, you have pretty much understood everything about EMF, internal voltage, and your internal resistance and your terminal voltage as well. All three concepts in one single example. Once again, guys, remember this: EMF is what they promised. What you get, that is called as a terminal voltage, because you're not going to get the exact amount that they say. So if you have a 1.5 volt battery, you're not going to get the entire 1.5 volt. You might get 1 or 0.9 volt. That is the terminal voltage. So what is the difference? What is the difference between what they promised and what you're getting? That is what is called as a voltage drop. So this small v, this is called as your voltage drop. That's all. This is the entire concept, people. So let's just quickly go through the theory part. So terminal voltage, once again, so if you have if you have electrolytic cell like this, so again, this is the electrolytic cell. So you see that this is basically what is called as a galvanic cell. So they have taken dilute sulfuric acid, dilute H2SO4, and you have zinc and copper plates. Those are the electrodes that is dipped into it, and you have a resistor, that is R. So see that the voltage across the resistor, across these two terminals, that is what is called as the terminal voltage. Or in other words, the potential difference when current starts flowing through it, that is what is called as terminal voltage. See, when no current is flowing through it, that is called as EMF. When current is flowing through it, that is called as terminal voltage, because there is a drop happening, right? There's a difference happening, and that drop, that difference, that is what is called as your voltage drop. Right, people? So if you have to conclude it, once again, terminal voltage is nothing but the work done. Again, it's nothing but the work done itself to move or carry a unit charge across the entire circuit from one terminal to the next, between the two terminals of the cell. That is what is called as terminal voltage. And again, it is represented by the letter capital V. And here the work done is W dash. So W, because what is that W? The other W is basically the work done to move the unit charge across the entire circuit. That is your EMF. This is nothing but the work done to move across two terminals of the cell. The terminals of the cell, that is what is worked. That is nothing but W dash, and W dash is nothing but the work done to carry a test charge inside or outside the cell. All right, not inside the cell, outside the cell, or in the external circuit. And voltage drop, again, guys, what is voltage drop? Like I told you, so voltage drop is nothing but, again, it is nothing but the work done itself. That is the work done to carry the unit charge inside the cell or inside the electrolyte. Inside the cell or inside the electrolyte, what is the work done? That is what is called as the voltage drop. So inside it's voltage drop, outside it's called as terminal voltage. The entire thing is called as your EMF. That's all. So that is how you conclude this particular topic, people. So again, the formula is small v is equal to W by Q. No, don't worry, guys, because we are going to be doing the relationship, or in other words, the derivation of EMF and terminal voltage as well. So it's very important, but it's very, very easy as well. So we know that work done outside and inside, basically the EMF is nothing but W. The EMF is nothing but W. And the work done outside the cell, that is the terminal voltage, is nothing but W dash. and the work done inside the electrolytic cell or inside the electrolyte, that is called as W. Basically the work done for it to move around. What is it? Again, like I told you, when it's moving around, there is some sort of resistance given to it. So the work done for the charge to move around inside the cell, that is nothing but W, the smaller W. So what I'm going to do is I am going to write it as W is equal to, so inside plus outside is equal to W dash plus W, because this W dash is nothing but the work done outside the cell. The small w is nothing but the work done inside the cell, right? So the work done for it to move inside the electrolyte. Now, what I'm going to do is I'm going to divide this equation by Q, all right, with nothing but charge. So it'll be W by Q, capital W by Q is equal to W dash by Q plus W by Q. Now, what is W by Q? That is nothing but your EMF. And what is W dash by Q? That is nothing but your terminal voltage. And what is this, a small W by Q? That is nothing but your internal voltage, which is nothing but small v. So what you're going to get is nothing but terminal voltage, or sorry, your EMF is equal to terminal voltage plus the voltage drop. Simple. Now, also people, we know that basically voltage drop is equal to current into resistance, or not capital R, will be small r, because the resistance inside the cell is smaller, so it will be small r. So you can also write this equation as EMF is equal to V plus IR, or you can also write it as V is equal to, that is terminal voltage is equal to EMF minus current into R. So this is one formula, people. This is one important formula that you will be using in the exams, in solving the questions as well. It's a very simple derivation, hardly 5 steps, and it'll be done. That's all, guys. So if you've understood this, do not forget to hit the like button. Let me know if you have any confusions in this, so that by the next session, if you want, I can give you more examples and try to make it as easy as possible. But again, guys, try to go back to that previous example again. Once again, I'm going to repeat this. The voltage that they promise, that is called as your EMF. What you get, that is called as the terminal voltage, because there is going to be a drop. The drop in that voltage, that is what is called as voltage drop, that happens inside the cell because of the internal resistance of the electrolyte of the cell. Simple. That is what it is, right? So this is the formula once again. So you can write this equation as V is equal to EMF minus IR. So this is a very, very important formula that we'll be using in your exams as well. So once again, so internal resistance is basically represented by a smaller zigzag line, and it is represented by small r. Again, what is internal resistance? The resistance offered by the electrolyte inside the cell because of the when the current is flowing, or when the charges are flowing. So the resistance offered because of the collision, that is what is called as internal resistance of the cell, because nothing is ever permanent, nothing is ever ideal. So we represented it as not capital R, we represent by small v, small v is equal to I into R. I is nothing but the current, and R is nothing but the resistance inside the cell, small r. All right, so that is how you represent people. Now for the last thing is, what is the relationship between EMF, terminal voltage, and internal resistance? This is also very important, very simple derivation again. So just to say it in perspective, people, we know that total resistance, the resistance of the entire circuit, is the external resistance plus the internal resistance, right? So capital R plus small r, where capital R is the external resistance. For example, if I have a circuit that looks like this, so this is nothing but the cell, this is the internal resistance. So this is the capital R, this is nothing but the small r, and this is nothing but the EMF of the cell, whatever that is, and this is the current I. Simple. So that is nothing but R plus R. Now the current which is coming out, which is drawn from the cell, I is equal to what? EMF of the cell divided by the total resistance, because why? V is equal to I into R. So I is what? V by R. Now what is V? V is nothing but the EMF, that is the total voltage or total potential difference, and R, resistance, is the total resistance. Not just the internal resistance, not just the outer resistance or external resistance, both internal and external together. You will find out what is the current, what is the actual current drawn. So basically this is what you're going to get. So EMF or I is equal to EMF divided by R plus R, where small r plus capital R. So I can say that EMF or E is equal to I into R plus R, right? Rearrange the equation. So what did I get? So let me just write it over here. So I saw that I is equal to V is nothing but EMF divided by R plus R. So rearrange the equation to get EMF. EMF is equal to what? I into R plus R. Simple. That's all I got. Now, the voltage across these 2 points, or the voltage across this one, because obviously that is the voltage across the other 2 points as well. That is nothing but capital V. So what is capital V? I into R, the current flowing through the circuit, into the external resistance. That is what it is. And the voltage drop is what? V is equal to IR. We've already seen that. We've already stated all of this. Now, what I'm going to do is, I am going to use the equation that I got before. That is, we saw that EMF is equal to the the terminal voltage plus the voltage drop, right? Now, we also know that if I rearrange this equation, what will I get? Small v is equal to the EMF minus the terminal voltage. This is what I got. Now, I also know that resist from the previous equation, that is V is equal to I into R. I know that R is equal to V by I. Simple, something that I've already seen. Now, V value we have already got from this equation. So what will I get? So R is equal to EMF minus the terminal voltage divided by I. Simple. So far so good. Now, what is I? I is what? The current flowing through the circuit. So current is what? Current is equal to V by R. So it's nothing but the terminal voltage itself, the terminal voltage and the resistance, the external resistance. So what can I write? So R is equal to E minus V divided by V by R. Simple. Simplify this equation. So what will you get? R is equal to R into E minus V divided by V. Simple. So I'm gonna, I can simplify this equation as R is equal to R into E by V minus V by V, right? I can write it like that. So V gets cancelled, so I'll get it as 1. So I'll get it as R into E minus V, E by V minus 1. That's all, guys. So the resistance, the internal resistance is equal to the external resistance into the EMF of the cell divided by the voltage minus 1. Simple. Right, guys? So again, I know that it might seem like a hard derivation, but trust me, it is not. Remember these symbols. We have already seen all of this. I've stated this several times already. So just look into this, people. Trust me, just practice it like 2 or 3 times and you'll easily get it. Again, the steps are given. Download the notes and make it your own. All right. Now, the last thing that I would like to say is what are the factors that affects the internal resistance, because yes, internal resistance are also dependent on certain factors. For example, the surface area of the electrode, that is something that it depends on. Distance between the electrode is something that it depends on. Again, more is the distance, more would be the resistance as well. The nature and the concentration of the electrolyte as well. Is the electrolyte something that gives more resistance or less resistance? That is also something that depends on. And finally, the temperature of the electrolyte as well, because again, if the heat is more, again the particles would move more randomly, so the resistance would be more. So all of these are the factors that our internal resistance of a cell depends on, right, guys? So I hope you are able to understand this. Once again, let me just confirm this. Let me just repeat it. EMF is what they promise. For example, if I buy a new one. Now, remember this, guys. If you keep using that cell, the voltage will also keep dropping. So when you buy a new cell, that is the EMF. When you use it, when you connect it to a circuit, because you're not going to get that 1.5 volt, you're going to get a lot lesser than that. You might get 1 volt or 0.9 volt or 0.8 volt. That is called as the terminal voltage. That is called as the terminal voltage. That is the voltage across the 2 terminals of the cell. That is the terminal voltage. The drop, the difference between what was promised, that is the EMF, and what we got, that is called as a voltage drop. Right, guys? So let me know if you've understood this in the comment section below. I know that it seems like a far-fetched theory, but it's very simple, guys. If you understand the concept, this entire chapter gets super duper easy. So let me know in the comment section below. Hit that like button, subscribe to the channel as well if you want to have more such amazing sessions and learn with such interactive fun way. Click on the link that is given in the description below, people, and it'll also be in the comment section, the pinned comment section as well. All you gotta do is click on that link, and people, that is gonna open a whole new world of online learning where you're gonna get unlimited live classes from the best of the best teachers with the highest level of quizzes in every single session. You have leaderboards, you can compete with the rest of the world and see where you're at, what you're good at, what you're bad at. You get the chance to know yourself. And apart from this, guys, you have the chance to watch all the sessions in the form of an interactive replay, because live sessions are going on 24/7 people, and it's not humanly possible for us to attend all the sessions. But nonetheless, even if you miss out a session, don't worry people, you can still take part in the interactive replay sessions and still take the quiz and still see the leaderboard as well, so you never miss out on the fun part of the session. And apart from these, guys, you can download all the premium content of every single session and the handwritten notes. Now the handwritten notes of these sessions also would be put up in the description below, so if you want to take it down, it'll be down there. But again, guys, make notes, make those notes. It's very, very important. Keep it with you, because that is what is going to help you in your final exams as well. So these premium content would help you to ace your exams, do much more better than what you think you possibly can. Apart from these, guys, you also have the chance to get your doubts cleared inside the session itself. You will not just have the master teacher, you will also have someone called as a class teacher to help you clear every single doubt inside the session itself. And other than this, that's not all people. You have 5,000 plus micro courses and crash courses, all for free for the price of one, people. If you just enroll into the pro subscription course, you're going to get everything. Apart from this, you'll be getting a lot more as well. So you're going to get a lot more for a lot less. Again, the link is given in the description, and the coupon code to avail discount is AME Pro, because the actual price is a little different. If you use the coupon code, you'll be getting discount as well. For example, if you go for the 1 month program, the base price is 2,699, but if you use the coupon code AME Pro, you get a discount of about 500 rupees. So what you're paying is about 2,159. And if you go for the 3 month program, you don't have to go for the 6 month program, people, because 6 month program is something that is not needed, because you have your exams coming up in 3 months. So 6 months, ignore that. So if you go for the 3 month program, the base price is around 6,999. If you use the coupon code, you get a discount of about 1,500 rupees, and what you'll be essentially paying is 5,599. Now think about it, guys. If you take the 1 month program, you would have roughly attended about 200 sessions on minimum. Minimum, you would have attended 200 sessions. So if you divide the total cost, divided by the total number of sessions, that's about 11 rupees per session. And if you take more number of sessions, you'll be paying lesser the amount. It's not going to be more. It's not directly, it's indirectly proportional. More sessions you take, the lesser money you're paying per session. So it's indirectly proportional. If you go for the 3 month program, you have done about 600 sessions. That is the minimum number of sessions you have done. You have gone up to 700 or 800 sessions. So what you'll be paying essentially is just 9 rupees per session if you go for the minimum number of sessions of just 200 per month. Which, if you think about it, is less than what we spend every day for a packet of American style creme and onion lace, right? So yeah, people, that is all I had to say. Now with that said, let's get into the quiz now. The link is given in the description. The coupon code is AME Pro. Again, guys, check it out. Trust me, you'll love it. Alright, here's the question. Now, pay attention. There are 3 questions, 3 very important questions. Trust me, these questions are super easy, but it's all about your thinking. How will you solve the question? The question is this. A battery of EMF 3 volt supplies current through a circuit in which resistance can be changed. The high resistance voltmeter is connected across the battery. When the current is 1.5 ampere, the voltmeter reads 2.7 volt. Find the internal resistance of the battery. The options are 1.5 ohms, 2.5 ohms, 0.2 ohms, or 0.5 ohms. Now, let me write down the given data first. So they've given me the EMF, which is nothing but 3 volt. They've also given us what is the terminal voltage. The terminal voltage, the voltmeter reads 2.7. What was promised was 3, but what you're getting is 2.7. So that is your terminal voltage, which is nothing but capital V, which is nothing but 2.7 volt. And they've also given you the current flowing through the circuit is nothing but 1.5 ampere. Now you're asked to find out what is the internal resistance of the battery. So what I'm going to do is I'm going to use the formula. Okay, I'll just use the formula. That is terminal voltage is equal to EMF minus IR, which is nothing but, or the actual formula is V is equal to terminal voltage minus the voltage drop. So that is the formula. So voltage drop is what? It's I into R. So that's the formula that I'm going to get. So this is the main formula, people. Remember this formula because you will be using these formulas in your exams as well. So write it down. Make sure that you write it in a sheet of paper and remember these formulas. Alright. So V is given as 2.7 and terminal voltage is 3 minus the current flowing through the circuit is 1.5 into R. So what are you going to get? I'm going to rearrange the equation. I'm going to take 1.5 R, it's minus, so I'm going to take it to the other side. So I'll get as 1.5 R is equal to 3 minus 2.7. So R is equal to 0. Okay, is this 2.37, right? So it's 0.3 divided by 1.5. So if you divide this, you will get it as, I believe you'll get it as 0.2 ohms. So that is I think that is the answer. Yes. So that is the answer, people. Very simple question. A very simple question. Again, guys, it's all about understanding it. That is why I took so long to explain the concept. I could have done it in a couple of minutes. I did not go according to that because I wanted you guys to understand the concept. I want you to make this concept clear. Do not get confused. That is why I took so long to explain this concept. So yes, guys, that is the answer for this question. Moving on to the second question. A cell of EMF 1.8 volt and internal resistance 2 ohm is connected in series with an ammeter of resistance 0.7 ohm and resistance 4.5 ohm as shown in the figure. What would be the reading of the ammeter? What is the potential difference across the terminals of the cell? So you're supposed to find out what is the potential difference across the terminal of the cell. That is nothing but your terminal voltage, and they're also asking you what is the current. So this is the diagram. So EMF is 1.8 volt. The internal resistance, that is small r, is given as 2 ohms. So these are basically the other two resistance. I'll take it as R1 and R2. So that is 0.7 volt, and sorry, this is okay. No. Yeah, it's not volt, guys. It's ohm. Yeah. The symbol is wrong. So they've given it as 0.7 ohms. It's not current. It is 0.7 ohms. And the resistance for the second resistor is 4.5 ohms. So yes, guys, how do we solve this question? It's actually a very simple question. How do you solve it? Is basically, we know the EMF of the cell is given as 1.8 volt. They've also given you what is the internal resistance. That is small r is given. That is 2 ohms. They've also given you what is the external resistance. So I'll take it as R1, that is 0.7 ohms, and R2 I'll take it as 4.5 ohms. So first thing, find out the current. So current is equal to V by R. V is nothing but 1.8 divided by what is R. Now here the R is the total resistance. So what is the total resistance? So R is equal to 2 plus 0.7 plus 4.5. So if you added 4, 5, 6, so that's around 7.2 ohms if I'm not wrong. So here it is 7.2 ohms. So 1 by 8 divided by 7.2, you will get it as 0.25 ampere. So if you divide this, you get as 0.25 ampere. So that is the current flowing through the circuit. Now that we've got this, let's try to find out what is the potential difference across the terminals. So you're asked to find out what is the terminal voltage. So terminal, this is the first part of the question. Second part of the question, you're asked to find out what is the terminal voltage. So terminal voltage is equal to EMF minus the voltage drop. So how do you, so we know the EMF is what, 1.8, but we don't know what is the terminal, what is the voltage drop. So voltage drop is equal to I into R. I is equal to 0.25 into the internal resistance is what, 2 ohms, that is the internal resistance. So into 2, you'll get us 0.5 volt. So that will be 0.5. So you will get it as 1.8 minus 0.5, you'll get it as 1.3 volt. So that is the answer, guys. That would be the answer for this question. I believe that is the right answer. Exactly. 1.5, 1.3. So now you can do it this way, or you can directly write it like this. V into I into R. So here R would be excluding the internal resistance. Excluding the internal resistance of the cell, which is 2 ohms, excluding that, add up the external resistance and you'll still get the answer. So this is also absolutely correct, or you can do it this way, whichever is easier for you guys. You can do it both the ways. Again, the notes you can download it in the comment section below, so don't worry, people. You can get it in the description, so don't worry about it. You can check out both the methods. Whichever you find is easy, you can go with that. All right. Last question, guys. Last question. All right. Figure shows a circuit which consists of a battery connected in series with a 10 ohm resistor. The potential difference across the resistors is measured to be 2.5 volt. If the internal resistance of the battery is given as 2 ohms, find the EMF of the battery. So they've given you the external resistance, they've given you the terminal voltage as 2.5 volt. You're asked to find out what is the EMF of the cell. Your options are 5 volt, 3 volt, 2 volt, or 6 volt. Again, guys, write on the given data first. So R is given as 10 ohms. They've given you what is the terminal voltage, which is nothing but 2.5 volt, and internal voltage, that is internal resistance, small r, is given as 2 ohms, right? So these are the things that is given to you. So what is EMF? EMF is equal to V plus V. That is the formula, right? If you remember from the first derivation, EMF is equal to terminal voltage plus the voltage drop. So terminal voltage is 2.5. Internal voltage is V is equal to I into R. Now I don't know what is the value of current, so let me try to find that out first. So current is equal to voltage is 2.5, resistance is 10. So because you're finding the current across this point, so you're going to find out the current over here. So again, the potential difference is given as 2.5 volt and the resistance is 10 ohms. So you'll get it as 0.25 ampere itself. So current is 0.25 amperes. So put that in this equation. So V is equal to small v is equal to 0.25 into resistance is given as 2 ohms. So you'll get it as again 0.5 volt itself, just like the previous question itself, 0.5 volt. So 0.5, you'll get it as 3 volt. That's all, guys. That is the answer for this question. The answer would be 3 volt. That's all. Again, the steps are given right here. You can take it down. Now, I used the main equation to get it. You can also use it this way directly. You can put on the values of, you can write as I into R plus R. That is the external resistance plus the internal resistance. You'll still get the same answer. Just calculate the current just like I did before and you'll get the answer. That's all, guys. So that is all for today. I know that the session was pretty long, but I hope you guys found this important, found it interesting, and also you understood the entire concept. This is your homework for today. Let me know what is the answer in the comment section below. Also, let me know in the comment section if is there any part that is still unclear. If there's any more clarification needed, let me know that in the comment section as well. I'll try to answer your doubts. All right. The homework for today is, guys, when current is drawn from the cell, its terminal voltage V is dash its EMF. When current is drawn from the cell, its terminal voltage V is dash its EMF. Is it going to be less or is it going to be more? Let me know that in the comment section below. Once again, guys, thanks a lot for joining today's session. Do not forget to hit the like button, and the link for the pro subscription course is given in the description, and the coupon code for me is AME Pro. Alright, guys, so that's it from my side. Thank you for joining. I'll see you in the next one. Take care of yourself, stay safe, and this is Anoop signing off. Take care, guys. Bye bye.